Okay, so we can use hydrolysis to help us identify a halogenoalkane. So if we have an unknown halogenoalkane, let's say it could either be chloromethane, bromomethane, iodomethane, we can use hydrolysis as a method to try work out which one it is. Okay, so it's just like we've seen previously, but we just add an extra step or two at the end. So the first step is just to do a hydrolysis. You take your halogenoalkane, you add sodium hydroxide to it, you reflux, and then to get rid of any extra hydroxide ions that are left over, we just add a little bit of nitric acid, dilute nitric acid, to remove that excess, because we don't want that interfering in the next step that we're about to see. But otherwise it's exactly the same as you've seen before. Aqueous sodium hydroxide, reflux, just like before. So, depending on which of those three we started off with, those three examples I looked at, the chloromethane, bromomethane, iodimethane, we'll get different products. They all make methanol, they all make the alcohol, but what's different is the side product. Okay, they're halide. So obviously this one makes chlorides, this one makes bromides, this one makes iodides. So the next step then is that if we can identify which halide ion has been made, we can work backwards and work out which halogenoalkane we must have started off with. Okay? So we've seen tests for halide ions before in Unit 1. We use the silver nitrate, aqueous silver nitrate, and the silver ion, Ag plus ion, will react with the halide ion to make different precipitates. So we can make silver chloride, silver bromide, silver iodide, and each one of those gives you a different observation. So if silver chloride is formed, you get a white precipitate, and that can dissolve in dilute ammonia. If it's silver bromide, you get a cream precipitate, and that dissolves in concentrated ammonia but not dilute ammonia. And then if it's silver iodide, that's a yellow precipitate, and that doesn't dissolve in either dilute or concentrated ammonia. So from those observations then, we can work out which halide ion is present, and if we know which halide ion is present, then we can go back to here and work backwards and work out which halogenoalkane it must have been out of those three unknown.